In this video, we're going to be using Google Sheets to process data to create a scatter plot, to find the correlation coefficient between two variables, to find the line of best fit, to calculate our predicted values, as well as calculate any residuals that we'll have, and make a residual plot. So the data we're going to be using comes from the USGS, and it's the Little Elm Creek near Aubrey, Texas, and it's the temperature of the water and its associated pH. So in this case, we're actually going to use the temperature of the water to be our explanatory variable and the pH to be our response variable. So in other words, we're trying to use the temperature of the water to determine and estimate what the pH would be. So now, to create a scatter plot, we just go ahead and hit Insert, Chart, and this will go ahead and insert a blank chart into Google Sheets. We can change the chart type to a scatter plot, which is right here. Now we can go ahead and add the data. So we add an X series. In this case, we're using our temperature as our explanatory variable, so that's our X variable. Now we can just go ahead and click on the letter to highlight the entire column of data, and we see here it says Sheet 1, exclamation point A:, meaning it's going to go to Sheet 1, find all the data in column A and use that. Now there are words in rows 1 and 2, however, because we're using a scatter plot, it's just going to ignore those, and we get a graph. Now we have to add a series, which is our response variable, so go ahead and click over here to add a series, and we're going to add our response variable, which is the pH, and so we'll add all that. Hit OK, and we get our nice scatter plot. So here we begin to see that we've got a negative correlation here because there's this downward trend of the data. So we expect that as temperature rises, the pH would decrease. Now to make a scatter plot look a little better, you can go ahead and add our titles to it. So we'll go ahead and add a chart title, which in this case we'll call Water Temperature versus pH. And then we'll go ahead and add a horizontal axis title. Again, that's our explanatory variable. And in this case, our explanatory variable is the temperature of the water, which in this case is in degrees Celsius. If I hit the right button, and then we can go ahead and add a vertical axis title, which is the pH of the water. Alright, so we have that. I'm going to go ahead and go to our series. I'm going to go change these circles, make them a little smaller, just so they're a little easier to see what the values are. Because with the larger circles, we went ahead and they were starting to blend into each other. So just to make them a little clearer, I'm just going to make them a little smaller, just to make it a little easier to see. Now I can go ahead and add a trend line. So in this series, in the Customize, we can add a trend line, and this is the line of best fit. It's kind of hard to see. It's kind of matching in with the points. So I'm going to go ahead and change the color, and I'm going to make it red. It's a little better, and I'm going to make it a little thicker just so it's easier to see. And it's a little too big. Yeah, I like that better, but I'm going to make it a little darker because again, I'm trying to get this nice line so we can see it. And again, it's going in a downward trend, which is what we expected looking at the data. We had a negative correlation, so we have this downward trend. And so for our label, I'm going to go ahead and make the equation. So this is the equation for our line of best fit. Again, we see that the coefficient of x is negative, which again predicts that tells us that we have a negative correlation. So again, we're having that negative correlation, that downward trend. So now in the C column, I'm going to go ahead and write predicted. So this is the values that we'd expect on the line. So these are the values associated with the line here. Now I'm going to go ahead and go equals and write in our equation that we have. The equation that the line of best fit equation gave us. So that equals negative 0.188 times our explanatory variable, which is temperature, plus 13.9, and go ahead and hit enter, and there's our predicted value. So based on our line of best fit, we would predict that our value would be 8.9. Now instead of having to do it for each individual column, because we look down here, we'd see that there is over almost 6,000 different points of data. We can go ahead and click on this cell right here, and in this corner, in the bottom right corner of it, double click, and it'll go ahead and fill in all those data and compute that for each one of these explanatory variables. So this is the predicted value. So now in the D column, we go ahead and write in residual, and the residual is just equals of the pH value, which is our actual value that we measured in the field, minus our predicted value, and go ahead and hit enter, and we see we have a negative residual. That means that our predicted value was higher than our actual observed value for that point. So go ahead and hit double click again, and our graph disappeared. Let's see why that did. So we'll go ahead and double click on that. Oh, it's because it added in this extra series in the A column. Well, let's go ahead and remove the variables that we don't want. We wanted temperature, we don't want that one. Oh, and I accidentally deleted our X value, so we'll go ahead and put that back. So our X is temperature, our series is pH, our response variable, so there you go. There's our data all back again. So now that we have the residuals, we can go ahead and create a residual plot. So we do it a lot like we did with this one. We go insert, a chart, move it off the data so it's a little easier to see, and I want it to be a scatter plot. So our X values is still the temperature of the water. Still the temperature is our explanatory variable. But now in this case, the series is our residual, which is in column D. So we'll go ahead and put that value. And we see our residual plot here. Again, I'm going to make it so that those circles are a little smaller because they're starting to blend in with each other. We don't need a line of best fit because this is the residual plot. But we do need some titles. So let's go ahead. First we'll do the vertical axis title, which is our residual. And then we'll do our horizontal axis title, which is our water temperature, which is still in degrees Celsius. And our chart title would be water temperature versus pH, there's a dash, residual plot, just to differentiate it between the two plots. Now we can tell it's a residual plot because all our numbers are close to 0. Our numbers are between negative 1.5 and 0.5, so it's kind of all around 0. And that's how we make the residual plot. Now the last step we need to do is find the correlation coefficient, which we'd expect to be negative value. So to find that, we can go equal, CORREL. You can see right here, that gives us the Pearson product moment correlation coefficient. Open parentheses, then we had our data. So we'll go ahead and add the A column for our temperature, and comma B column for our pH. That's because those are the two variables that we're trying to correlate. Close parenthesis and enter, and we see we have a negative 0.687 correlation. So we do have a negative correlation. It's a pretty good strong one. It's kind of on the weaker side though. Now if instead of putting in the A column first, we go equal CORREL, open parenthesis, B colon B comma A colon A, we would get the exact same correlation coefficient. So it doesn't matter which variable you put in. If you put your response variable first or you put your explanatory variable first, it doesn't matter. The computer will compute it the same way.